Okay, today we're going to start our second chapter of the Further Maths Year 13 work, looking at series and summation of series with a method called method of differences. A lot of it is to do with partial fractions. So we've got an example here where we need to split up this expression as a partial fraction, and then we're going to use the fact we've got a minus here to do something called method of differences. So first off, we're going to show that this nice straightforward. Let's rewrite it as 1 over r bracket r plus 1 is equivalent to a over r plus b over r plus 1. Get rid of the fractions. A bracket r plus 1 plus br. Stick in our values. R equals 0, 1 equals a. R equals minus 1, 1 equals minus b. And there we got our answer. So we can show that our expression is now equivalent to 1 over r minus 1 over r plus 1. Now we need to find the summation of this thing. The fact is r equals 3 to 35 is almost irrelevant. What I don't need to do, I don't need to change it into 1 to 33 or anything like that. I just need to put in the values. So this summation here, when I stick in r equals 3, I'm using the fact that it's the same summation as the two fractions there, 1 over r minus 1 over r plus 1. And I stick in 3 to get 1 over 3 and minus 1 over 4. And then the next r value would be 4, so when I stick in 4 I get plus 1 over 4 minus 1 over 5. Well, what's going to happen is these things here, the 1 over 4 and the minus 1 over 4, are going to cancel out. And when I stick in r equals 5, the plus 1 over 5 and minus 1 over 5 are going to cancel out. Everything is going to cancel out in the middle apart from that first term. And when I stick in r equals 35, I'm going to get dot 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 plus 1 over 35 minus 1 over 36. That is going to cancel out there. I'm going to be left with just two terms. A third minus 1 over 36. Let's change it so we've got 12 minus 1 all over 36, 11 over 36. There we go. So everything cancels out apart from some terms at the start, some terms at the end. In this case it was just one term there and one term there. What's left will have a sort of rotational symmetry aspect to it. So I've got a single term there, I'll be left with a single term down there. Let's try our second example. Use the identity. 24r squared plus 2 is equivalent to that thing cubed minus that thing cubed. To show, and it's a standard result, sigma r squared equals n over 6 n plus 1 2n plus 1, and let's have a look how we do. I'm going to consider summing up all this expression here. So I'm going to do sigma r equals 1 to n of all the 24r squared plus 2, and it's going to be equivalent to r equals 1 to n 2r plus 1 all cubed minus 2r minus 1 all cubed, and stick in 1 and I get 2 plus 1 3 cubed minus 1 cubed, stick in r equals 2, I get plus 5 cubed minus 3 cubed, and hey presto, we start cancelling out there. I'm left with just the one term there. I can go dot dot dot, and when I stick in r equals n, I get plus 2n plus 1 all cubed minus 2n minus 1 all cubed, and everything would have cancelled out apart from that term at the top and that single term at the bottom there. So it becomes the same as 2n plus 1 all cubed minus 1 cubed. And I can simplify that as being, when I expand it, 2n all cubed, 8n cubed, plus 3 plus 12n squared, plus 3 times 2n plus 6n, plus 1 minus 1. Now let's have a look at the other side though, because I can simplify that nice and straightforwardly. The sigma 24r squared plus 2 is the same as 24 sigma r squared plus 2 lots of n. Don't forget I'm summing that n, sorry, that 2n times. And that equals my 8n cubed plus 12n squared plus 6n when they cancel out. Move that across, divide by 24, and I've got what sigma r squared is. Sigma r squared equals 1 over 24 bracket 8n cubed plus 12n squared plus 4n. Take out 4n to get 4n over 24, and it's looking good. 2n squared plus 3n plus 1, and that cancels down to n over 6, n plus 1 to n plus 1. And that's our factorised version there, exactly what it should be with our standard result. Okay, the third example is an interesting one. It's not a partial fraction like most of them are. It's a factorial one. So we're given that f of r equals r factorial. Part A, I show that. I show that f of r plus 1 minus f of r equals r times r factorial. So this is where we're going to introduce our differences. So f of r plus 1, so let's look at the left-hand side then. F of r plus 1 equals r plus 1 factorial minus f of r, which is r factorial. Well, I can rewrite this as r plus 1 times r times and so on, so it's times r factorial minus r factorial. So it equals r times r factorial plus it and minus it. They cancel out to leave you with the show of that there, which equals the right hand side. So we're good to go. Hence find the sum of this expression from r equals 1 to n. Well, this is going to be the same as the sum from r equals 1 to n of f of r plus 1 minus f of r. So I'm going to stick in 1, f of 2, which is 2 factorial, minus f of r, which is 1 factorial. And then stick in r equals 2 to get plus 3 factorial minus 2 factorial, and there's where our cancelling out comes. Notice, by the way, the circling of what's left is key, because of I can then quickly go to the last line and realise I've got just the one term that I'm really after here, which is when I stick in r equals n to get n plus 1 factorial minus n factorial. That's the term that's left there. So I'm just left with n plus 1 factorial minus 1 factorial is minus 1. And there's not a great deal I can do with that. And that's a massive product, and that's a single term. So that's my expression. Last example I've got is a longer one. It says, given that, and this example's done the start for us. It's split up this expression as the partial fraction. Quite often in exam questions you'll be asked part A to go from that to this, and then use it to do the part B, which to show that the sum of this expression equals n bracket 5n plus 9 over 2 n plus 1 times n plus 2. So let's have a see how we go. All I'm going to do is use the fact that the left hand side is the same as the sum, r equals 1 to n, of 2 over r minus 1 over r plus 1 minus 1 over r plus 2. And just start sticking r equals 1 in, r equals 2 and see what happens. So I get 2 over 1, just leave it as that, because it might be useful, we'll see, minus 1 over 2, and then minus 1 over 3. Stick r equals 2 in, get 2 over 2, minus 1 over 3, minus 1 over 4. Nothing's really happening here. I've now got to go down to a third line, stick r as 3 in, and get 2 over 3 minus 1 over 4 minus 1 over 5. And the cancelling actually appears here along this diagonal there. The 2/3 minus a third is going to cancel out, as is that one when I get 2 over 4, as is that one when I get the 2 over 5 and minus 1 over 5 and so on. And I'm left with these 3 terms here. So similarly, I'm going to be left when I have the penultimate line and the last line with the 3 terms in this corner, with that sort of rotational symmetry aspect. So I've got to consider when I stick in r equals n minus 1, I'm going to get minus 1 over n minus 1 plus 2, which is minus 1 over n plus 1. And when I stick in r equals n, I'm going to get 2 over n, which is going to cancel out, minus another 1 over n plus 1, and then minus 1 over n plus 2. And those are my, all in all, 6 terms that I have left. So these ones are a numerical one. These have got fractions there that I need to then lump together to get one expression. So let's have a look at what I've got. I've got 2 over 1, 2, plus 1, 3, minus a half, so it equals 5 over 2. There's a 5 in there, I'm liking the looks of that. Minus 2 lots of that fraction, 2 over n plus 1, minus 1 over n plus 2. I'm going to stick it all over my common denominator, which is my answer. That looks good. I've got 5 lots of both brackets, n plus 1, n plus 2, minus 2 times 2, don't forget the 2 there, times n plus 2, and minus 2 bracket n plus 1, squishing it all in. I can't really do much here apart from ties it all out, so I'm going to get 5 lots of n squared, 3n plus 15n plus 10, minus 4n minus 8, minus 2n minus 2. And luckily, let's have a look at what I'm after. Yeah, the plus 10, the minus 8, the minus 2 cancel out, which is looking good, because I don't have any constant in the top of my answer. I'm left with 5n squared plus 15 minus 4 minus 2 is plus 9n over 2, n plus 1, n plus 2. And I'm showing enough now, I can take an n bracket 5n plus 9. You don't get any marks for the last line, but it needs to come from correct working. And it's always a good idea to rewrite it anyway, so you're sure you got it. And that's my right answer, that's my proof.